Good morning. It's exactly 5:30 and it's dark o'clock here, and it is Friday, July 25th, 2014, and we are having a Uncle Pete's Corner again. Number 32, by the way, and he's going to talk about something that's near and dear to his heart, and that's structured arrays. Go for it, dude.
All right. Good morning. So I got you all excited about the structured arrays, and then put you off a week, and I found out who were the already addicts in the group, because several guys started having shakes because they had to wait an extra week for the talk on structured arrays. So I'm not the only one that has found the structured arrays. Andy definitely has found them. Bob loves to play with arrays, and I know there's several guys on the group that do a lot with arrays. They are just they're an absolute lifesaver, and they can solve a ton of problems for you. They're a building block that once you understand them and can start building on them, the uses are endless. For all the clearing guys in the group, the IP driver, at the end of the day, that's just a fancy interface to arrays. It's all about having stuff in memory. Andy's classes, if you really simplify it and boil it down, it's just a super fancy access to arrays. So it's very important to understand that foundation, because once you understand that foundation, what's going on in those classes makes a little more sense to you. How you could change, tweak, extend those classes starts making a little more sense to you. So it's very important to understand the basics of arrays, the different types of arrays, and especially structured arrays, because you'll use them again and again. You'll see them used in a lot of places that you may not be realizing that that's what's being used. But once you get into it, you'll start seeing it. So I'm going to start today with a review of arrays and the basics, and just build up until we get to structured arrays, because there is several guys in the group that either came from languages that didn't support arrays, shudder the thought, or because of what they worked on or whatever, they just never got exposed to arrays. So I know there's a few groups in the guys in the group that just really haven't had much exposure to arrays. So trying to jump straight into structured arrays might be a little tough. So we're gonna screen through some basics of arrays and then move into the more complex stuff. And this is a good approach, because as we do this, you'll see that it'll take some of the mystery out of structured arrays, because there's really nothing different about a structured array than a standard array. If you start with structured arrays, you kind of think that they're more complex and complicated, but they're really not. They're just another form of an array. So let's start with the basics. Just what is an array? An array is multiple instances of the same variable. Some academic is probably losing sleep right now over that definition, but that's really what it is. It's just, we have a variable. We need 12 of that variable, instead of declaring 12 variables, we declare an array of that variable. Now we can have 12 instances of that variable. The number of instances, which those instances in array speak are called elements, can be either fixed or dynamic. In other words, you can define up front, I'm going to have 12 copies of this variable. Or you can have that number be dynamic, meaning I don't know how many copies of this variable I need, but every time I need one, I'm going to create another copy of it. Some of the terminology that we're going to use a lot when we're talking about arrays is an element, which is one specific instance of the array. Subscript is the numeric reference to that element. If we have 12 instances, 12 elements in our array, subscript 3 is that third element in that array. We have a total of 12, and each one is numbered 1 through 12. So that's what a subscript is. Dimension is where things start getting a little fancier. You can have a multiple dimension array. And I don't use those as much, and we'll talk about them a little later. We'll get into them very briefly, but I don't run into a lot of uses for multiple dimensional arrays, especially since I can also do structured arrays. So I just don't find much need for them. As I said, we also have fixed and dynamic, meaning the number of elements can either be defined up front, or we can add elements to it on the fly. A simple array is what those that started and have used arrays have probably seen the most. It's just an array based on a simple variable type. Now, one important distinction to understand about arrays is every copy of that, we said that was multiple instances of a variable. Well, because it's multiple instances of that variable, every instance is the exact same definition. So if that variable is an int, all 12 copies have to be an int. Otherwise, it's not a copy. So, I mean, when you think about it, that makes perfect sense, but it's a key concept that you really have to understand to work with arrays. It's every copy of that array is the exact same type. So a simple array is an array based on a simple variable type, an integer, a string, currency, Boolean, whatever. Then we get into the couple of items that are the real cherries on top of the cake that WX gives us, that not every language gives us, and that is structured arrays. A structured array is an array based on a complex, a variable type, a structure, a class. And that's kind of the point of this article. As we move forward, you'll see that it's very much the same thing. It's just that data type, instead of just being an int, is a more complex data type that has individual bits and pieces to it. But it's still a single type. It just happens to be a complex type. And then we have associative arrays, which associative arrays is probably the one that is most foreign to most programmers. A lot of programmers probably have not been exposed to associative arrays. They are an indexed array. Instead of, we talked about subscripts, of one, if we had 12 elements, those elements were 1 through 12. That subscript was 1 through 12 to access each individual element of that array. Well, an associative array that subscript is actually a key. So instead of being a numerical incrementing subscript, it can be anything. It could be a string, it could be a date, whatever. And now we're able to access the individual elements in that array by that key. Just like we can access them by that subscript, we can access them by that key. And that brings some very powerful things to the plate, especially when we start talking about the fact that we can have associative structured arrays. But you know, that is pretty far down in our conversation. So we'll get to those as we move on. But just know that the two that really bring the power to us are structured arrays and associative arrays. So now we've got some definitions out of the way. Let's talk about just what the heck are arrays, why would we use them, and get some basics out of the way. A requirement that we probably have all seen at some point is carrying 12 months of sales. Absolute old school, no arrays, we'd have to declare 12 variables. January total sales, February total sales, March, on down the line. So we now have 12 variables. Then to get a total sales, we'd have to add up those 12 individual variables. Which, you know, I bet back in the day we've all wrote code similar to this. Let me tell you, at RPG I sure did, because we didn't have fancy-dancy arrays. Which that code's not the end of the world, but just how easy would it be to have done June here instead of July? Just looking at that code, it'd be very hard to notice that bug. And that bug might go on for 2 or 3 months before someone catches it. And now we have people making business decisions off of incorrect data. You know, so every piece of code you write is another opportunity to introduce a bug. So the simpler you can make your code, the better off you are. Something else that would be real hard to do is displaying a table control with these 12 months in that table control. You'd have to do it, because there are 12 individual variables, you'd have to write code for each row to assign that row to the variable for January, February, March, on down the line. So I'm not even going to show you that code because, you know, I'm just too lazy. So then it gets even more complex. What if you had to suddenly, instead of tracking the 12 calendar months, they wanted to track 12 rolling months? I always want to see the last 12 months of sales data. Well, you know, let's even ignore the fact that our variable names now don't make well, basically like this. We'd have to move February's totals into January, March into February, on down the line, and then clear December so that we can start adding December sales, you know, the current month. Again, these variable names no longer make sense to you because you're doing 12 rolling months. But as you see, this is, again, code that it would be extremely easy to make kind of typo in and now you've introduced a bug into your rolling logic as well.
By the way, I kind of messed up and I muted and unmuted everybody. So if you're not speaking, mute your mic, please. Thanks.
So that's the old school world that you know, those of us that had to write RPG and other languages like that definitely had to deal with. I think COBOL had arrays, didn't you, Andy?
That is so old ago, but yeah.
So old.
I'm trying to remember.
You're so old ago.
20 years ago since I did the last COBOL. Let's see, last one I touched was 1998. Was the last one I touched. Y2K projects.
That's like after we met, Andy.
Yeah, I know. But see, you're old too.
So yeah. Anyway, you know, I doubt, other than the few of the younger guys in the group, all of us have written code similar to this code at some point in our illustrious past, and it sucks, and it sucks a lot because it is so easy to introduce bugs to this code. So arrays to the rescue. And again, we're just talking about simple arrays as a foundation here. So let's start with, we need to track 12 months of sales. So we do monthly sales as an array of 12 currencies. All we did was say we're going to have monthly sales, our variable. We're going to have 12 instances of it, and it's a type of currency. This is something that WX does that most languages don't, is they actually plural the data type when you're defining an array. But IntelliSense takes care of that stuff. Nothing we have to do. And in fact, I think you can actually do currency here, and it works just fine. That's another one of those things that they do that I'm not sure exactly why they do it. Now I can't get it back to currencies. There we go. So now we have those 12 instances we talked about of our array. Now, our data, and I'm just going to put a little bit of data in there so that we can do a little playing. So all I'm doing is looping through here and setting each month equal. So we're going to have 1, 2, 3, 4, up to 12. Nothing fancy there. So now, remember this god-awful statement to get total sales? Well, now that we're storing each month's sales in an array, how do we get total sales? Well, it's tough. Total sales equals sum monthly sales. And just like that, we've summed up those 12 arrays because it knows that they all belong together and that they're all the same data type. We're able to issue a special function called sum that just sums up that array and gives us the total. Now, this, not as much opportunity for you to make a typo and introduce a bug into that statement. Now, where it really comes in handy doing all this is when we wanted to put that table control on the screen. Remember I said because of our 12 individual variables, we would have had to code each row and all of that nastiness. Well, with WX, we can actually base our table control on a variable, and that variable being an array. So all I've done is say, hey, I want a table control based on a variable. I'm going to use my monthly sales array, and then this column is based on that element, each element of that array. And if we run this, we see 1 through 12, which is what I did in that little loop. So now we've got a table control showing those 12 months of sales on the screen, zero coding. Remember, with the 12 individual variables, I didn't even write the code because I was too lazy to write that much code. And now I'm able to do it with zero code. Now, the rolling month example, that one you think might take a little bit more work. Well, it takes 2 lines of code, so it is a little bit more work. We delete line, which is an array function. We remove that first month. So we're removing the first month of sales, and then we add an element to the array. So when this line executes, we would be down to 11 elements in our array. Then this line, and there's multiple versions and syntaxes of array adds and deletes and so forth that I'll give you the link to the online help page that gives them all to you. But the one that we're using here, all it does is tack on an element onto the end. So by deleting the first element, everything shifts down. So now month 2 became 1, 3 became 2, on down the line. And then we add 1 to the end. So what we just did was that code with these 2 lines of code. So again, not nearly the amount of opportunity to introduce a bug into our code. In fact, everything that we did here with this 31 lines of code, we've done with 1, 2, 3, 4 lines of code. And we were able to put it on the screen with 0 lines of code. So you see, in very simple terms, what arrays bring to the table in the ability to supercharge your code. And right now we're only at the PBR level of arrays. We've got a long way to go. And if you don't know what the PBR level is, then you're not a cheap drunk like I am. So now let's just talk about a couple of quick tips for arrays.
Are you talking about Pabst Blue Ribbon?
I knew Arnie would get the reference.
Hey, is there any disadvantage to arrays then? I mean, you're showing some really good advantages.
I wouldn't call them disadvantages. There are some gotchas, and we're going to bump into a couple of those as we move on.
Okay.
I don't know that I'd call them disadvantages, but there are a few gotchas that you should keep in mind.
All right.
Let's talk about just a few different shortcuts and different tips and things concerning arrays. WX gives us a shorthand for assigning arrays. For instance, here, month names is an array of 12 strings, and then I can assign all 12 of those with a statement like this. Now, that's much nicer than having to do array add, month names, comma, January, on down the line. I can do all 12 in one fell swoop. I use this syntax a lot. I have, in most of my programs, I generally have some type of set of fixed lookups where there are lookups that I want to show on combo boxes and stuff, but they're not something that the options ever are going to change. You know, they're defined at the beginning and never change. States is a prime example. Salutations, you know, Mr., Mrs., Doctor, Captain, whatever. So those type of things I'll tend to define like this somewhere in my initialization code, and then my combo boxes can be based on that array. It just makes for nice, clean code.
If you wanted to read from a file to populate that, though, you would have to do it the add array way, right? By the way, February is misspelled.
No, no, you've just been misspelling February.
Okay.
Actually, there is a command called file to array, which we get into when we get into structured arrays, which will absolutely supercharge everything. But there are ways to move a file into an array, a CVS into an array, and so forth, so that you can have one command that populates your entire array and moves data around. It's very, very powerful stuff, and we'll see some of that as we move forward. Okay, so looping through an array, we already saw that up here when I populated the 12 months with data. All we're doing here, you know, this is just a loop 1 through 12. For each loop, I'm referencing that subscript. That's what's inside the square brackets, is the subscript of that array. So the first pass, it's 1. I'm saying the first element of monthly sales equals X, which is 1. And then the second one, the second subscript is going to equal 2, 3, 4, on down the line. Now, the reason I'm able to do this is because we made a fixed array of 12. So those 12 elements already exist. And we'll talk about dynamic elements a little later also, and you can see how that affects some things. Now, we can also, instead of doing that syntax, we can also do, let's look at a couple other ways that we could have done that loop. Like for here, we want to get total sales. Say we didn't know about the sum statement because, you know, we're a moron and we don't check the online help. So to get total sales, we could loop through the array and total up sales. So we could loop from 1 to the array count, which array count is another function that says how many elements are in the array. So that translates to, for X equals 1 to 12. Total sales increments by whatever that element, because again, we're using the subscript over here. So we're getting monthly sale, the first element, second element, on down the line, and we're totaling up total sales. So that's one way we could loop through the array. But WX also has these very cool browsing syntaxes, and I use these a lot for all kinds of things. And there's a lot of different variations of them. For this one, we're saying, okay, so for each monthly total of monthly sales, so that we're looping through monthly sales, same as we're doing up here, but now I don't have to worry about what the count of the array is or anything. This statement says, make a pass for every element of monthly sales and put the value in this variable. Now notice monthly total isn't declared anywhere. How in the heck is that working? Well, it knows that monthly sales is an array of currency, so it's dynamically declaring monthly total as a currency variable. So now I can loop through and say total sales plus equals monthly total. Now that doesn't look like it's that big of a difference from our 4x statement, but when we get into dealing with structured arrays, where this is a complex variable type, you'll see that this syntax starts becoming very handy. So it's a good syntax to understand how it works. Now, say we needed that subscript for whatever reason. Well, we could use this syntax. We could do this syntax and increment, create a local variable and increment it by 1 with each pass. Or we have yet another variation of the browse syntax that says for each monthly total, comma, subscript of monthly sales. And what this does is it puts the value of monthly sales into the first variable and the subscript into the second variable. So with each pass of this loop, monthly total is going to be the value of 1, 2, 3, 4, and subscript is going to tell us we're dealing with the first element, the second element, the third element. Doesn't make a lot of sense right here. Not a lot of reasons that you would need to use it here, but when we start getting into structured arrays and associative arrays, you'll see where this syntax comes back and becomes very handy. So, you know, that's one thing as you start working with arrays. And these are also not only used for arrays, but these browsing syntaxes let you loop through table controls, looper controls, files, queries. So these browsing syntaxes are definitely something that if you haven't seen them, used them much, you need to break out the online help and dig into them because they're handy. Okay, so far we've been dealing with our fixed. Remember, we said there were 12 at the very beginning. We said we're going to have 12 monthly sales because we know there's 12 months. But when you're dealing with arrays and data, you don't always know how many you're going to have. Well, you can declare an array without saying it's a fixed number. Now, this is what's known as a dynamic array. It's not a fixed array. So at this point, with this definition, there are no elements in this array. It's an empty array. And then we could add a couple of elements to it with the array add statement, just like we saw before. And now, if we did an array count, we would find out that there's 2 elements in that array. When you start dealing with dynamic arrays, you start introducing the opportunity for runtime errors again. For instance, if we executed this code, we get a runtime error. Looks like we actually got our runtime error somewhere else. Was it there? No, it was there. Okay, so what it's saying is the array has 2 elements. We can't access element 3. You know, it's saying, hey dummy, you only have 2 instances of this array. Why are you trying to look for instance 3? So that's, as you see, that's an opportunity to introduce a runtime bug. You know, compiler can't help you with this because it doesn't know what what you've done that may or may not have created an instance of the array. So it doesn't know that you're not going to have 3 at this point. But when we run the code, we run into a runtime error there because we're trying to access an element of the array that doesn't exist. Well, WX actually gives us a couple of ways to handle that. And I will admit these are statements that I haven't really used a lot, didn't really know they existed. I don't know how common they are in other languages or not. Just not something I'm real familiar with, but I could see some instances and different reasons that they would come in handy. So let's take a look at this example. So now let's declare that array the same as we did before, but we're using this special growth equals 1 option. That says that I can access one element greater than however many elements are in my array. So now when I create my 2 elements, and then I try to access the 3rd element, I don't get a runtime error. It automatically creates it. So after this statement issues, there will be 3 elements in my array because it says grow by 1. So when I try to access 3, there are 2 already. It says, okay, I can grow this to 3, so I'll get a 0 here, or actually an empty string because we're doing a string. But if I try to access element 10, I'm still going to get a runtime error because I only said to grow by 1. So let's run that real quick. See, we get a empty space for element 3, but then we get a runtime error when we try to access element 10 because that's still too far out of our range. Then there's actually yet another syntax. She used to find comments. Now this, instead of saying grow by 1, I said grow by n, which says you can go as big as you need. I never want to get a runtime error because I tried to access a subscript that doesn't exist. So now when we run this, you see we got spaces for both of those. We didn't get any runtime errors because when 3 hit, it added that element. Now here's, and Arnold, you asked about, are there any disadvantages? And I said no, but there are some gotchas. Here's a gotcha. Understand that when this statement issues, in fact, let's do this right here. It says that there are now 10 elements in that array. Array count is now returning 10. So understand that when this statement issued, there were only 3 there. I tried to access 10, so it created 4 through 10. Doesn't sound like a big deal, right? Well, what if I did some really horrible coding and wound up with some god-awful number like that in my subscript? That's bigger. insufficient memory. It ran out of memory trying to create all those elements. Because remember, it didn't just dynamically access this element, it had to create all the elements between 3 and that number of elements. So that is definitely something to watch out for if you use this growth in. It'll let you keep from getting a runtime error because you're accessing an element that doesn't exist, but by the same token, it's going to let you run rampant with memory. So there's one of your caveats. So now, a couple other things we can do with arrays. We can sort arrays. Let's start with an unsorted array of strings. You already saw this syntax earlier. I'm putting GAF on down the line in them. Now we can sort that, sending just like that. Now if we run this, look at it in the debugger, and we see that it sorted it A, B, C, D, E, F, G. So very easily we were able to put our random data into the array and then sort the array. And what's important to understand about this as we move into the really complex stuff is sorting 1,000 records in memory much faster than sorting 1,000 records on disk. So that's another area where the File Manager classes that this all eventually leads up to starts taking advantage is because those records are in memory instead of on disk, sorting them different ways, and now you can sort your tables any which way because all you're doing is sorting the array. You're not re-accessing that data off the disk. Now, funny, sad side note, and if anyone wants a slightly used function that does this exact same thing, Teamology has a very complex function that will randomly mix up your array because I needed that for my multiple choice questions for surveys. I didn't know there was an array mix statement.